Hello, once again. Welcome back with another video. In today's problem, we are going to see transpose of a matrix, and this is an easy problem again in the linear algebra section. So we'll first read the question, write a Python function that computes the transpose of a given matrix. So we all know what is a transpose of given matrix, right? To understand better, I'll just have this as a matrix, and I can write 2, 3, 4, 5. Okay. And what is the transpose of this matrix? So you just rotate this, which means in the first part you would be getting 1, 4, 7, 2, 5, 8, and then 3, 6, 9 is 9. Okay. And what is the relation that you would take as the diagonal elements are the same, 1, 5, 9, 1, 5, 9. And if you see this closely, 1, 4, 7 is actually in this part. So in a matrix, you are going to see for each row, and you are going to make each row as columns. So for first column, it will be the first row of this one. For the first for the second row of the second column, it will be the second row, and vice versa. So how do you implement this efficiently in Python, right? So and input sizes can be varied. It might not always be the case. You will be getting an square matrix or n by n matrix. You will be getting 2 by 3, in this case rows into columns 2 by 3, and you have to transpose it efficiently. So let's get to the code. So what I'll be doing is I'll just try it in brute force way in Python. How do you solve it? So you have 1, 4, 7, which I want to make this as row. Okay. So I'm going to go through the first row. If you let's see this, I'm going to see the first row, which is 1, 2, 3, and I'm going to take the indices of that, because I know for a fact that if the columns are 3, which means I have to iterate for each column, and for each column I have to take the rows row numbers of those 2 columns, and then have to make this as an array, and then make this as a column, which means 1, 2, 3, 4, 5, 6, 1, 4, right? Which means in the first row first column, in the second row first column. So you see a pattern that is emerging, right? So I'm going to go through the range of a of 0. A of 0 consists which gives the length, which gives the number of columns, and for each columns I am going to have the a of 0 comma I, and a of 1 comma I, a of 2 comma I. If this is clear, I think 0 comma I, which is 0, and 1 comma, in this case you have only 2 rows, so we'll have this aside. So for each row you would be getting 2 numbers, which is 1 comma 4, which is from first row first column and the second row first column. And for the second iteration you would be getting first row second column and the second row second column, which is 2 comma 5, which is this. and so on like that. So why don't we implement this also in a loop, right? I can make this as j or something like this. In Python we can do something like this for j in a range of length of a, which means I'm going to iterate through the rows, right? 2 rows means I'll be getting 2 numbers. So this is our array. I can say something like b dot append something like this, and if you say b equal to this, I think you'll be getting it. Yes. So it's almost like n square complexity. So we don't have to care much about that, but we can optimize this again, for example, for I in range length of 0, 0, right? So I can say something like this, right? And instead of this we can take this and like this. Okay, I think for I comma j you can take this variable and okay, I accept that. It's single liner, but we can also try to optimize this by using Python. In Python we have a function known as zip. Zip, if you see this, right, zip of a, for example, let's take an example. Let's start Jupyter server. Okay, now we can have this. Okay, we have 1, 2, 3. You can have my name Sujay, can have Akshay, and you can have can say zip of a comma b. Okay, zip of a comma b. Usually it would give me Sujay comma I, for example, if you kind of print this. Yes, 1 comma Sujay, 2 comma Akshay, 3 comma Ram. It is usually used in creating data loaders when you have different data coming from different things, and you have to attach some label to that data. So it's very much useful in those scenarios. We can leverage this. For example, we have, let's say, a list of 2 comma 2 and 2 comma 3. And if we say zip of a comma a, or zip of a, invalid syntax, okay. You have this one for okay, sorry. This cannot be interpreted as an integer. Okay. Okay, sorry. I forgot. Yes. Now you have 2 comma 2, 2 comma 3, and you cannot find something like this. Now this matrix is actually transposed. which is you are taking 2 comma 2 and 1 comma 3. This is actually the transpose matrix. You can actually use this. For example, you can say something like zip of star A, and this contains uh, all the tuples in that scenario. So what you can do is you can try list it, and you would be getting the output as tuples, and you can say list of I for I in zip. So I think it's not. Okay, so yeah, this is very simple, and this is the optimized method. So if you see the numpy np.transpose function, right? Numpy transpose function. Yes. If you see that, we can also try these examples with that. Transpose of single array should again give us a single array, so that is an edge case we should try. Okay, so we can say import numpy as np dot transpose. I can say 2 comma 1 and 2 comma 3. This one goes that, and we'll just copy our matrix and transpose matrix of 2 comma 1 and 2 comma 3. Okay, so as the output is in list, you can also convert this into numpy array if you want, and it will give the same answer. Let's try this, and how do you actually get this? So yeah, okay, so why is this giving error? Because A takes only these things, but I know what is the problem of trying this. Okay, but in this case, right, it will give you the exact number 1 2, let's say 3 single array, because you cannot transpose a single dimensional array, which is essentially a vector or something like that. So you can say something like zip of this matrix and list of I, and you can say something like this S 2 1 3. So when you have a single dimensional array, you would be getting the same things, but the problem is you are getting as an multi-dimensional array. You can probably reshape as -1, but still it's easier to, if it's not a multi-dimensional array, you can just return the array itself, but this function clearly accepts only the multi-dimensional array, so we need to take care of that. So where does the transpose of a matrix is very useful? It is again useful in self-attention. We actually transpose the value matrices again. First we randomly generate some matrices, and then we transpose it, and then we help the model to learn all those values, queries and keys. So but it also used in one of the convolutional layer, right? So if you see the GAN paper, generative adversarial networks, it actually uses this part, this type of convolution for generating images. It was very useful, and essentially it actually changed, from there diffusion models came up, and DALI and all these models started bringing their own type of convolutional layers. De-convolution is one of the type, or also known as the transpose convolution, where you just kind of rotate the kernel matrices in a CNN functions. we'll try to implement these things in a deep learning method, but this is very useful. And even if you kind of see self attention method, right? Attention formula. Yes, you're trying to transpose this function, so you have to effectively do that. So this is one kind of way to doing it. For the next thing, we will probably see linear algebra. We will see transformation matrices from basis B to C. This is also very useful. Reshaping the matrix, it is probably used in every project. Okay, if you see any any Python project which uses deep learning or computer vision, they should use reshape, tensor dot reshape, vectors, np dot reshape. They I mean, in tensors or pytorch we can also use view function, but reshaping a matrices is very much useful. It's probably used 99% for all projects. Okay, if it doesn't use it, it's probably using some traditional ML methods where you don't need reshape functions. Don't need to reshape the input data. So that is very much important. We will also see that, and effectively we have to implement as fast as possible. So that's it. If you have any better methods for what we just did right now, transpose of matrix, please comment below. That's it. Thank you.